Okay, good afternoon everybody and welcome back to this next TechnoLive starter session. I hope everybody is keeping well and I hope everybody is staying safe during these rather crazy times. So like I said, welcome back. I hope everybody is well, and what we're going to be doing during today's session is we're going to be taking a look at MakeCode Arcade, okay, which is something new that we haven't yet looked at, but we'll be doing this through the use of block-based programming, okay. So like with other things that we have looked at over the last few weeks, there have been numerous different languages that we can use to help program our programs, okay. And today we're still going to be looking at block-based programming, but there are options like before to use Python and JavaScript, okay. However, we will be using block-based programming today. So during today's session, we will be here to help you. So if anybody does want any help, or if there's anything in particular that anybody is stuck on, or if anyone has any questions, remember we are here to help, and you can contact us via the TechnoCamps webpage, which you should hopefully all be able to see on your screens now. If you navigate to the TechnoCamps webpage, so technocamps.com, you are able to chat with one of us. So both myself and my colleague Joe will be monitoring the chat facility that we have today. You can just simply click on Chats with one of our delivery team down here, which is in the bottom right hand side of the screen when you click onto the TechnoCamps website, and if you follow the instructions you'll be able to connect with one of us and have a chat with one of us about any questions that you might have during or on today's tasks. In addition, like with the start of every TechnoLive session that I do, I just wanted to draw your attention once again to the various different competitions that TechnoCamps are currently either running or are part of running. So on the TechnoCamps website, if you scroll down to where we have our latest news, you'll be able to find here our Game of Codes competition, which is based on education of the future. And during this competition, you will have to create a piece of software that follows the theme of education of the future. And you can write this program in any coding language that you like, okay? From scratch, and Python, all the way through to things like HTML, or even you can produce something on a BBC microbit. And of course we looked at BBC microbits during the first week of the TechnoLive starter sessions when we were programming them to produce some kind of fireworks display. Okay, so this is one of the competitions that we have running, and I would suggest that you take a look at this if you're interested. We are running this for the next few months. You have until Friday the 19th of February, so plenty of time to keep working on this. Okay, you might have started already, which would be fantastic, but if you haven't started already, you still have enough time to start thinking about that. And we have got, of course, several like I said, different languages that you can do this in, and all of the instructions can be found on the TechnoCamps website, so I would suggest that you have a look at those there. In addition to that, we are also running a Minecraft Stadiums of the Future competition. So again, this is something that is produced in Minecraft, and if anybody would like more information about that particular competition, then of course don't hesitate to get in touch and we'll be able to share that with you. Okay, so remember, if you do need any help during today's session, we are available to help you, and feel free to contact us through the chat facility on the TechnoCamps website. So without further ado, we'll make a start on what we're going to be looking at today, which, like I said, was MakeCode Arcade, or arcade.makecode. Okay, so what I would like everybody to start off with doing before we get into the main into the main bulk of today's tasks, is navigate to the MakeCode arcade.makecode website. Okay, so the URL is on my screen now, so it's arcade.makecode.com, or you can type it in on Google, and you should be able to find it. And you should then, if you're on the correct link, you'll be brought to this page, okay, which is the arcade.makecode homepage. And again, this is something that has been produced, or or works, that's been developed further with Microsoft. So lots of very useful kind of things that you can use on this website. And there are, for those of you who are interested, after this session, multiple different tutorials, different things that you can look at, different lessons that you can work through, which are available on the website. So if anybody after today's session is inspired and would like to continue working on their projects or on a new project, there are numerous different tutorials available on the MakeCode arcade.makecode website. Okay. One thing that I will point out as well is that I've got all of these different programs that I've already created, okay, which are all called similar things. It's likely that you won't see any of these on your homepage if you haven't used arcade.makecode before. So just bear that in mind, that you probably won't see all of these. Okay, so there's no need to worry if this part is just completely blank. These were just numerous tests that I was performing. So the purpose of the arcade.makecode website is it allows us an opportunity to try and create games. Okay, so arcade, as the name would suggest, we all know, I'm sure, what an arcade is, and this platform is designed so that we can produce our own computer games. Okay, so the first thing that you need to do is click on New Project, and then you can give your project a name. So in this case, I will call mine TechnoLive, but of course you can call it whatever you like. And as well, if you do expand that code options menu, just make sure, and this should be the default, but just make sure that you've got it set to blocks, JavaScript and Python. Unless you did want to challenge yourselves and program a little bit more in Python or JavaScript, that's of course absolutely fine. But if you have it set to blocks, JavaScript and Python, it means that you can use all three languages in the same window. Okay, so it's worth just making sure that it is kept on blocks, JavaScript and Python. And then once you're satisfied that you've given your project an appropriate name, you can click on Create. And then you'll be brought to this screen here, where, as you can see, we're seeing a very, very similar window to that of what we've been using in the past. Okay, so we've used this sort of window in the past, where we have, it's very similar to the microbit, the BBC microbit platform, okay, where we have, but in this case we have our gaming, our portable gaming device here. Okay, so it looks a little bit like a Game Boy, okay, like a Nintendo Game Boy, and it is on this screen that, if I enhance it, it is on this screen that we will be seeing our game when it is completed. Okay, and of course this, now that I've expanded it, looks a little bit more like possibly the bottom half of a Nintendo DS. Okay, so very similar. So, like before, we have our coding zone here, which is where we're going to be placing all of our blocks. Okay, so this is where all our blocks are going to go. And under these menus on the left of the screen, we have all of our different blocks which we're going to be using today. Okay. Now, of course, I'm going to be going through the blocks required for today's session, but remember, if there are any particular blocks that you would like to add yourselves, or anything that you believe would be good to add into your game, then you can do that. Okay, I'm going to basically be going through quite a basic template of the game today, but you are free to add as many different things as you like to your game. Okay, so feel free to be as creative as you like. You can also search for specific blocks if you can't find them in a list. And as well, of course, like before, we have the option of toggling between JavaScript and Python there. Okay, if anybody wants to see those. Okay, so let's make a start on today's game. Like I said, what we're going to be doing is essentially programming a very basic game. I'm going to be creating what appears to look like some kind of room, okay? And in that room, I'm going to have a small character that is being chased by some kind of ghost, okay? And the objective of the game is to try and not get caught by the ghost. So that is what we're going to be producing today. Like I said, you are free to choose any type of sprite, as you'll see in a second, that you like. You can pick, there is no sort of limit to your creativity here, okay? You can be as creative as you like. Like I said, I'm just going to be giving you more of a template to work off, and you can kind of expand it from there, okay? So the first thing, we are going to be keeping this on start block here, okay? And the first thing I'm going to do is bring in my player sprite. So to do that, I can go into sprite, and then I can use this set my sprite to block, which is the first one that we see in that list. And I'm going to drag that into on start. Okay. Now at the moment, this sprite is called my sprite, which is fine. And if I click on this grey square here, I am able, from the gallery, which you can click on the top of the screen, to choose one of several different possible characters. Okay, there are lots to choose from. I'm going to choose this one, okay, but the choice is yours as to which one you would like to select. Okay, so I'm going to go with this particular sprite, and then I'm going to click done. And in doing so, we can see that I've also got my sprite set to of kind player. Okay, so this means that this sprite that we have just popped into the game is a player sprite. So it will be controlling this particular sprite. Now we of course also need our ghost, which is going to be chasing us around our map. So to do that, we do exactly the same thing. We go back into sprites and we get set sprite. Okay, I'll set my sprite, which of course in this case what it's done is it's changed it to being my sprite 2, because we've already got my sprite in the game. But I'm going to change the name of it to, I'm going to call it enemy. Okay, so I'm going to call it enemy. So what we have here is our first potential mistake. Okay, so apparently we've already got a variable that's called enemy, so as a result we can't use that name, but that's okay. So we can maybe call it something else. Let's try my enemy and see if that works. Okay, there we go. So now we've got my enemy. So you can rename your variable, in this case your sprites, to being whatever you like, but I've just called it my enemy for now. Okay. I also now need to choose my enemy sprite. So again, I'm going to click on that grey square, I'm going to go to gallery, and I'm going to choose my enemy sprite. So again, there are lots that we could possibly choose from, but I'm going to go with this character, which is some kind of, I believe it's some kind of skeleton. So I'm going to choose, let's go with this one. So there we are, there's my sprite, and I'm going to click done, and we can see now that I have my sprite inserted into the game. Now of course we need to tell our game what kind of sprite this enemy is. So we can change its kind, and you can see that we have projectile, we've got food, and we've got enemy. I'm going to choose enemy because this skeleton sprite is going to be the enemy, and this sprite here is going to be our player. Okay. Now at the moment what you'll probably see is that over on the game, on the left of the screen, you've got both of your sprites, and they're both overlapping with each other. Okay, so we can't see, we can no longer actually see our player sprite because it's hidden behind our enemy sprite. So in a second, what we can do is we are actually able to tell our game that the enemy sprite needs to start in a different place. So it kind of gives our player sprite a little bit of a head start before the game starts. So that way the game doesn't instantly end because the enemy sprite has instantly caught your player sprite. Okay. So what we can do is we can go back into sprites, and we can choose a starting position for our enemy sprite using this block here. So it says set my sprite position to x0, y0. So if we drag that into there and change my sprite to being my enemy, we can then redefine the position that our enemy sprite starts. Okay, so of course we need to say that our enemy sprite starts in a slightly different place. So to give my playable character a little bit of a head start, I'm going to choose, and you can use this graphical interface version here where you just simply select values, or you can use the slider, or you can manually input a value using the keyboard. Okay, but what I'm going to do is I'm going to use this graphical interface, and I'm going to say that my enemy sprite is going to start about here. Okay, so it doesn't matter where, I'm going to say there. So now, when the game starts, we can see that my enemy sprite, which by the way you can start by pressing this play button down here, my enemy sprite has now moved away from where my playable character sprite is, giving my playable character sprite a little bit of a head start. Okay. Now, like I said, this is a chase game. Okay. Where our enemy is going to be chasing our player around the map. So as a result, we need to ensure that our enemy sprite follows our playable character. And we can do that again from the sprites menu. And in this list, we'll be able to find, it's in here somewhere, I've probably gone past it, let's have a little look, let's see, there it is. So we've got this block here which says set my enemy follow my sprite. Okay, I'm going to use that block, I'm going to pop it in there, and if I click on this plus symbol, I can choose the speed in which my enemy sprite follows my sprite. Now currently that speed is set to 100, so if I click play, we can see that the enemy sprite very, very quickly catches up to my playable character. And of course that's no good, because this would be a completely unfair game, because before we even get going, the enemy sprite has caught up with us. So what we can do is we can change this speed, and I found, personally, a good starting speed to be around 10 units. Okay. So now, if I restart, we can see that the enemy sprite takes a lot longer to catch up with the player sprite. Okay, it takes a lot longer. So this is now a little bit more of a reasonable speed, let's just say, for our character to kind of be chased at, because otherwise we wouldn't be able to actually get away. Now, with this being a type of game which of course involves, I guess it could be similar in a way, you could think of it as being similar to some kind of platformer, we do need to have our camera follow our sprite, okay? Because if the camera doesn't follow our playable character sprite, it means that we can go to all kinds of different places on the screen, but the camera is going to remain fixed at one point, which is no good, because we're not going to be able to then know where our character is, what direction our character is facing, where the character is, and things like that. So from this scene menu, we can choose this block here under camera, which is camera follow sprite my sprite. Now if I pop that in there, what will happen now is as I'm moving around the game, and now naturally we haven't actually programmed our game to follow, to move the sprite yet, but once we've done that, what will happen now is our camera will follow the sprite, our playable sprite, as we're moving around the game. Okay? So hopefully that's all made sense so far. If anybody has got any questions, then please let me know via, of course, communicating with us through the TechnoLive website, okay, with a chat with one of our delivery team facility, okay. What I'll do now is I'll just give everybody a few minutes to try and get caught up, okay, and then we will we'll carry on in a second. Whilst everybody's getting caught up, I will just mention that there is the download option, some of you may have noticed, in the bottom left of the screen. Okay, there are of course a whole bunch of different download options. What you can do is actually download your game as what we call a PNG file, okay, which is basically a type of image file. And what you can do is you can save that to your computer, and when you load up MakeCode Arcade after a period of not using it, or if you wanted to carry on working on your project, you can just simply click and drag that PNG file into the coding zone, and it will bring up all of the blocks that you'd previously put into your game. Okay, so it's worth, at the end of this session today, downloading your game, saving it to your computer, and then just in case in future you decide that you would like to use it again. Okay, so hopefully that's given everybody a little bit of a chance to get caught up. Okay, so we've made good progress so far with our game. We've imported both of our sprites, so both our player sprite and our enemy sprite. We've redefined the starting position of our player sprite, of our enemy sprite, so that we're giving our player sprite a little bit of a head start. We have told our enemy sprite to follow our player sprite, and we have changed the speed so that it doesn't instantly end the game as soon as we start it. And we've also told our game to follow the sprite, okay, our player sprite, as we're walking through the game. Now at the moment, a lot of you might have noticed that the game looks a little bit bland, okay? We simply have the player character and we have the enemy sprite and nothing else is happening. So what we can do is we can now actually set a background, okay, which is also known as a tile map. So from the scene menu, we can choose the set tile map to block, which is just here. Okay, and I'm going to just add that again to my on start block. Now, if we click on this smaller grey square, you'll be brought to this screen where we're able to actually draw our own tile map. Now you can draw your own, okay, so you can do things using the various different tools that are available in the game. But one thing that I would recommend is that you take a look at these options here, where we have forest, we have aquatic, we've got dungeon, and we have miscellaneous, okay? And all of these have different menus that you can use and different tiles that you can use within your game to kind of design it a little bit more, okay, and add a little bit of a design element to your game. So like I said, we've got forest, aquatic, dungeon, and miscellaneous. I'm going to choose dungeon, but again the choice is yours as to which one you would like to use. Now, what these blocks all kind of represent are different things that you can place on your tile map. Okay, so there are numerous different choices, and what you'll notice is that there are a lot of these corner pieces, which of course are going to be placed in the corners of your map. Okay, now I'm going to be selecting some of these corner pieces now as I make up my tile map, and I would suggest that you look for the corner pieces first, similar to how you would do with a jigsaw, and then afterwards choose the rest of the blocks that you need to make up the rest of the walls. Okay, so you select an option, so let's go with the top right corner, and you simply slide over to the slide your mouse over to that corner, left click, and then it places the block down. And if you make a mistake, you can select the eraser tool here and click on it and it removes it. Okay, but you'll need to make sure that you go back onto the paint tool, which is that pencil symbol, in order to replace the block. Okay, so I'm just going to find all of my corner pieces. So I've gone for this green sort of brick tile design. Okay, so I've now placed all of my corner pieces, which means that my map is now going to contain all of these corner pieces. Now, of course, I need to make up the rest of the wall, so I'm going to choose a couple of tiles. So I'm going to kind of use sort of that, and then maybe I want a little bit of broken brickwork here and there, so I'm going to choose different tiles. Okay, so the choice is yours, what you'd like to go for. Of course, remember there are different tiles for different sections of the map, so you'll need to make sure that you've selected the right one. Okay, so I'm going to go with placing some of these blocks down here, maybe a little bit of broken brickwork towards the end like that, and a couple more here. Could even place, oh, I'm not sure about that actually, I might get rid of that one for now. Just go back with this one. Oh, need to make sure I'm clicked on pencil. There we are. Okay, and just do this side. Whoops, wrong one. There we go. There we are. So you can see now that I have produced all 4 walls, okay, but I also need to, of course, have some floor, because currently it's just going to look like my characters are walking around in an empty abyss, and that doesn't look particularly good. Okay, so what we can do is we can choose these tiles. Okay, so I'm going to choose a couple of tiles. I'm just going to place sort of in the map here. I'm going to put a couple of broken ones in. Okay, again, the choice is yours how you choose to do this. Okay, you can just kind of randomly sort of scatter them around, maybe mismatch tiles here and there, that kind of thing. Okay, it's entirely up to you how you choose to design it. But I'm just going to pop all of these in. Obviously, if you do accidentally place one in the wrong place or something like that, you can remember just simply use that eraser tool to delete them. Okay. So again, just placing a couple of these here and there. Again, it's completely up to you how you choose to design your map. There we are. So just make sure that you've placed down all of the tiles that you need, that it kind of fills the void a little bit, because otherwise you're going to have kind of like black spots on your gaming console, on your virtual gaming console, and of course that's not particularly, it doesn't look particularly good if you have a lot of kind of like empty space. So just make sure that you've filled all of your tile map. Okay, and you're going to end up with something that looks somewhat similar, to what I have on my screen now. Okay. Now I know that some of you might want to spend a little bit more time designing, but what I will do is I will carry on with the next stages, but feel free to pause the video and then carry on once you've finished your tile map design. So once you have finished, you can just click on this green done symbol. And what you'll notice now is that my tile map, that grey square, has now changed to containing what looks like a very rough outline of my tile map. Okay, as you can see here. And if I now restart my virtual game console, we can see that I have now got my map. Okay, that is now loaded onto the screen here. So let's take a look at that in action. So you can see now that I have got my sprite, I've got my enemy sprite, I've got my wall, and I've got all of the tiles. Okay, so we've essentially now managed to set up a simple game which contains an enemy, a playable character. We've set it up so that it's a chase game. We've got a nice little tile map, and we've got our camera to actually follow our playable character sprite. Now, so far, what we're seeing here is a good example of an algorithm. Okay, so we've talked about algorithms in our previous live streams, where we've mentioned that we have a sequence of instructions which tells our computer what it needs to do, because our computers are of course very, very clever machines. Okay, they are able to do lots and lots of different things. However, we need to of course remember that we need to tell our computers what they need to do. We have to be able to program them and tell them and give them instructions, and this is what we're doing by building up this algorithm. Okay, we're building up our sequence of instructions, and that's going to be used to tell our computer what to do. Okay, so I'll just leave this code up on the screen for a second, just to make sure, just so that everybody can verify that they're in the same place and that they have all the same blocks. Okay, remember we are still here to help. Joe and I are still here to help. So if you do have any questions, follow that link on the Technocamp's homepage, and we will give you a hand as best we can. Okay. Okay, so hopefully everybody is now caught up. Remember, you can pause the video if you need to. Okay, so we have now managed to get our game to have some sort of tile map. We've got our enemy, we've got all of that going, but of course one of the fundamental problems with the game currently is that our playable character can't actually move. Okay, now this is of course a bit of a problem because in most computer games you are able to actually move and do certain things. Okay, because otherwise it'd be quite a boring game if you're just sort of standing still and you can't interact with the game at all. So we of course now need to get our playable character to move around the game, okay, so that we can escape from our enemy sprite. There are numerous different ways that you can do this, but I'm going to go through the simplest option because it only contains 2 different blocks. Okay. So the first block I'm going to use is from the loops menu, and we have of course talked about these loops before. Now the onStart is an example of a loop, but we've talked about lots of different loops before. So we have our for loop, which only executes code a specified number of times, which is very similar of course to our repeat loop. Okay, our repeat 4 times loop. So we would be telling it this, all the code that's inside of this block will need to repeat 4 times. We have got our while loop, which runs based off of a condition. So if a certain condition is true, it will execute some code. If that condition is not true, then it won't execute any code. Okay, or it will jump to the next part of the program that comes after the while loop. So those are some examples of loops, but the loop that we're going to be using today is the forever loop, okay, which is located at the top here, and I'm going to click and I'm going to drag that in. So the forever loop is a very important loop because it allows code to be repeated, as the name suggests, forever. Okay, so it keeps running code forever and ever and ever, over and over and over again, until essentially we stop the program from running. Okay, so this forever loop is going to be doing just that today, and this is going to be used in conjunction with allowing our playable character to move around the map. Okay, so we're going to pop this forever loop in here, and I'm going to take a block from the controller menu, which is just here. As you can see, there are lots of different options. Okay, we've got move my sprite with buttons, we've got on a button pressed, which again you can change to being lots of different types of buttons, okay, and things like that. Oh, which, by the way, if you do need to delete certain blocks of code, you just simply drag them and place them onto basically drag them back to where you got them from, and then they will disappear. Okay. But, like I was saying, we need to be able to control our sprite in some way. Now, from the controller menu, you will see that we have this move my sprite with buttons block. Okay. I'm going to drag that and I'm going to pop it inside of the forever loop, which essentially means now that our playable character, our player sprite, will be able to move around the game using the arrow keys. Okay, so it'll simply use the arrow keys to move around the game, as opposed to us having to, I guess what we would say, hard code those particular buttons to do certain things and manually program a certain velocity, okay, so the speed that our character moves around the world. We can simply use this move my sprite with buttons block, which will by default allow our sprite to move around using the arrow keys, and we can specify, if we click this plus symbol, the speed, okay, which our sprite can move. Now currently it moves at a speed of 100 a Vx100, Vy100, which means that when it's moving both horizontally and vertically through the level, it will move at a speed of, or at a velocity, that's what the V stands for, of 100 units. So if I enlarge my game, hit play, we can see that as I'm hitting the arrow keys, my sprite is moving through the game. Okay, we can see that the ghost is indeed chasing us. Okay, and we can also use the manual kind of joystick here as well. Okay, if we wanted to do that. So this is our sprite now moving through the game, but it's moving at quite a substantial speed, which is it's a speed which our ghost or our enemy sprite can't really keep up with us. So I'm going to reduce the speed a little bit. Now I've found that since our sprite, our enemy sprite, is moving at a speed of around 10, in order to make sure that again our enemy sprite can't instantly catch us up, I'm going to choose a speed of 15, okay, for both the Vx and the Vy values. And if I now restart my game, you can see that we're now moving at a much slower speed, but it's actually much harder to try and keep away from that enemy sprite. Okay, it's much harder because we're only moving a little bit faster than it. Okay. Now, of course, you can increase the speeds for everything. So, for an example, I could increase the speed of my enemy sprite to being something like 14 if I wanted to make it a little bit more intense and a little bit closer to call. If I restart now, we can see that my enemy sprite is actually catching up much faster, and it's much harder again to try and get away because we're only moving 1 unit of velocity faster than the enemy sprite, and I'm pretty sure we can say there that it's already really caught up. So to try and make it a little bit fairer, I would recommend that you keep your enemy sprite moving at a slower speed to your player sprite, but of course you can choose any values that you like if you want the game to be a little bit more fast paced. But again, I'm going to go with 15 for my player sprite and 10 for my enemy sprite. I'm going to zoom out a little bit and just leave that code up on the screen. Again, I'm going to leave that there just for a second, just so that everybody can get caught up, and then we'll move on in a moment to figure out a way that we can get our game to essentially end if our enemy sprite catches up with us. Okay, so I'll leave that code on the screen. Any questions, remember, feel free to ask. But I'll leave this code up on the screen for a second, just so that everybody can try and get caught up, and then we'll move on in just a moment. Okay, so like I said, the last thing that we need to do now, I'll just zoom in again a little bit, is we need to have a way of our game coming to a little bit of a close. Now, of course, like I mentioned earlier, the purpose of this particular game is we have an enemy sprite that's chasing our player sprite, and so of course the ultimate objective of this game is to try and stay away from the enemy sprite. And so if the enemy sprite does eventually catch up with us, we need a way of telling the game to reset okay, if our enemy sprite eventually catches up with us. Okay, whoops. So if our enemy sprite catches up with us. So the way that we do this is as follows. If you go back into the sprites menu and you scroll down, you should be able to find a block that says on sprite of kind player overlaps other sprite of kind player. Seems a little bit confusing, but I'm going to drag it in and I will talk through what it means. So what's happening here is if one of our sprites, which is of kind player, now we'll remember earlier that we set my sprites to being of kind player, okay, overlaps with another sprite of kind at the moment it's set to player, then we want some codes to run. Okay, so essentially what this means is that if a sprite that's of kind player overlaps with another sprite that's of kind player, we want to run some code. But of course we've only got one player sprite in our game, and the second type of sprite that we have is our enemy sprite, which means that what we need to say is on sprite of kind player overlaps other sprite of kind enemy. Now of course you could say this the other way round in a way. You could say of kind enemy overlaps with other sprite of kind player. You know, I'd imagine it would work both ways, but what we're essentially saying in this instance is that when our player sprite is when the enemy sprite, or our player sprite overlaps the enemy sprite, when the player sprite overlaps the enemy sprite, something is going to happen. Okay, because if we test our game again currently, what we can see is that our enemy sprite is coming, overlapping, it's caught up, and then the game just sort of ends. Okay, well, the game just sort of carries on even. You know, nothing in particular actually happens. So we need to tell our game what to do when our player sprite comes into contact with the enemy sprite. Now, of course, one thing I think that would be a good way to kind of show when that happens is a kind of message box. You know, something that sort of suggests that the enemy sprite has caught up. You know, some kind of visual cue. So from the sprites menu again, we can see, if we scroll down, a block that says my sprite say smiley face. Okay. Now if I drag that and pop it in there, I can change this to being, well, we can set it to my enemy or my sprite. It's up to us, you know, which one what sprite we would like to say something is up to us. But I'm going to choose my enemy, and I'm going to change the smiley face to being something like, I don't know, let's just say got you. Okay. Now we can, if we hit that plus symbol, change for how long our sprite actually says that. Okay, so there are different choices, different, you know, milliseconds or seconds. I'm just going to stick with 500 milliseconds. Okay, and before the game restarts, I would like there to be a little bit of a pause between when the enemy says got you and when the game restarts, so that we have enough time to kind of register that the game has ended before it restarts again. Now some of you might have noticed earlier that inside of the loops menu here we have this block that says pause 100 milliseconds. If I click and drag that in, put it there, this means now that before I add so if I were to add more blocks after the pause, what would happen is they wouldn't run until the duration in the pause block has passed. Okay. Now, however long we choose this pause to last is up to us. I'm going to just choose 500 milliseconds again because that seems like a reasonable amount of time between pauses, but of course you can do 1 second, which is of course 1000 milliseconds, and things like that, but I'm going to stick to 500 milliseconds, which seems to me like just enough time for there to be, enough time for us to register that the game has ended and that we need to wait for our playable character or for the game to reset. Now, inside of the game menu, there is a really simple block here, reset game, which essentially will, after the game ends, or after we're caught up by the enemy sprite, it will basically reset the game, okay, and put us back at the start. And I'm going to put that block after the pause. So to just summarize this block of code here, we have got on sprite of kind player overlaps other sprite of kind enemy. So when our player sprite overlaps a sprite that's of kind enemy, which of course we can reference back to these two blocks here. We want the enemy sprite to say got you for 500 milliseconds, so that's going to appear, as we'll see in a second, like some kind of speech bubble. Okay. Once that's over, we're going to have the game pause for 500 milliseconds. Okay. So of course 500 milliseconds would be around half a second. And as soon as that's over, we're then going to reset the game. So essentially the game is going to start afresh, and we're going to start in just start the game over, essentially. Okay. Remember, there are lots of different blocks that you can use, but all of these blocks should be sufficient for our game. So if you are unsure about what any or what certain blocks do, remember, and I've mentioned it during today's session, you can add comments. So by right-clicking and clicking on Add Comment, you can add a post-it note style comment here to your block, and you can write something in it. Okay, and then what you can do is you can hide that. And when you click using that arrow, when you click on it, you can see that the post-it note appears. You can drag it to a different part of the screen. Okay, it's very, very useful. But that's just in case you wanted to try and remember what a certain type of block does. Now, if I hit play on my game, we can see that I've got my enemy sprite moving around. I am able to move around as the player character. I can move around my map. I have got all of the walls set up. I've got my tiles set up, and we can see that if I get caught by the enemy, it says got you on the screen. That could maybe be a little bit longer, okay, because it happens quite quickly. But you can see that as soon as I get caught by that enemy sprite, got you appears and the game restarts. Okay. Now, of course, like I said earlier, we could change these around, so I could say when type enemy overlaps other sprite of kind player, the same thing happens. Okay, so it doesn't matter what order they're in. But we can see that maybe we could have our enemy say something for a little bit longer, so let's change that to maybe 1 second and see what what effect that has. So not too bad, okay, but you can see that, as usual, the game restarts after each time the sprite catches up with us, okay. Now, there is a menu on the Virtual Games console that's already programmed in, so there are different kind of choices here that you can make for your game. So you can do that by clicking on the menu button, but of course the game screen is where you're able to control your sprite. And of course, like I said, there are lots of different buttons. We've only controlled the joystick style button today, but there are lots of different ones. You can control that using the actual buttons on the screen, or you can simply use the arrow keys on your keyboard to do it. Okay? And you can stop or start the game using this stop or start button. Okay? And this one here restarts it. So that is how we create a very, very simple game using MakeCode. Okay? So just to summarize what we've just been through, we've started, every time the game starts, which is what this onStart block is doing, we're importing our first sprite, which is of the enemy sprite, so that the player sprite has a little bit of a head start before the enemy sprite can try and catch up. And we've set the enemy sprite to follow the player sprite, but at a slightly slower speed, so that way the enemy sprite doesn't immediately catch up with the player sprite and instantly end the game. Okay. We have, of course, also set the camera to follow the sprite, our player sprite, as we saw as I was moving through the map a second ago, and we've also, of course, designed our very own tile map. We have programmed our sprite using a forever loop to continuously move using buttons with the velocities, okay, of 15, so the speeds of 15 units, so that's slightly faster than the enemy, just so that we can always have that little bit of a head start, but of course you can program the values as you wish. And then we have also specified down here that our sprite of kind player, if that overlaps with a sprite of kind enemy, we want the enemy to say got you because it's caught us up. We would then like the game to pause, okay, or the game doesn't pause per se, but the code pauses for 500 milliseconds, so half a second, and as soon as that's over, it then restarts the game. Okay. Now, like I mentioned before, for those of you who wanted to be a little more adventurous and challenge yourselves a little bit further, you could program this in JavaScript. So if I click on JavaScript, we can see this here kind of talks about all of our... This is exactly the same code that we've got here under blocks, but it's written in JavaScript instead, which is what we can see here. And of course we can also see it in Python. So Python is another type of text-based programming language, and we can see that that code for Python is on the screen now as well. So again, identical code to what we're seeing in block-based programming, okay? Ooh, whoops. But written in Python instead. Okay. So for those of you who are interested, you could maybe pause the video or have a look at your own JavaScript and Python code to see what you think, and to maybe try and make some, make some sense of what each particular line of code is doing. Okay. So I'm just going to leave that code on the screen for now, which is of course all of the code that you need for today. Okay. To program your simple game. Remember, you can be as creative as you like. You don't have to stick to what I've done. You can be as creative as you like. You can, choose your own character sprites. You can choose your own enemy sprite. You can have multiple enemy sprites. There are lots of different things you can do. The possibilities are endless. Okay. But I would suggest that you take a look at this. Often, code will be saved to your online account. Okay, this save button here will download your project, like I said, as an image. Okay, which when you need to access it, you can simply drag and drop it from your file explorer to a coding zone, and that will then simply launch the game that you've built before. Okay, and often as well, if I click on the home page, you'll see that I have actually got my TechnoLive section, saved on my home page, and that would normally be there as well if I leave and then come back to the game a few days later. Okay, you simply click on it in order to access it. So that is about all that we have time for today. I hope that everybody has enjoyed today's session, and that it's gone, and that you've learned something new about game design. Okay. Next week we will be back once again for another TechnoLive starter session, which will be at the same time on Tuesday. Okay, between 4:30 and 5:30. Next week we will be doing something slightly different. So we will actually be trying to demonstrate to you some of the really cool features that we have available on a flight simulator. Okay, now that is of course our plan. Hopefully we're able to stick to it and that all goes well. Otherwise it will be something slightly different, but hopefully we can get that all working, and next week we'll be looking at some cool features that we can find in a flight simulator. Okay, so once again, thank you very much everybody for joining in today's session. Remember remember to take a look at the Technocamp's website for our Game of Codes activity, or of course to get in touch if any of you are interested in the Minecraft Stadium of the Future program, competition even. Okay, so we'll wrap everything up there. Once again, thank you very much. I hope everybody has a good week. Take care, and I will speak to you all very soon.